Thanks, Maryam. You can get started.
Okay, cool. I presume people can see my screen.
Yes.
Okay, cool. So today we're going to go over some of the proposed cable driver enhancements that went in over the last quarter. And really, I guess the goal of today essentially is to try and find or identify an owner for the enhancement proposals moving forward. There's 3 of them that are still open in the enhancements repo. The first one is related to enabling a central certificate authority to issue IPsec or to issue certificates for the gateways to use as part of their IPsec connection setup. The second enhancement proposal is related to essentially enabling different cable drivers between clusters through the use of a new type of policy. And then the third enhancement proposal that actually has a reference implementation is for a new cable driver that is using VXLAN over IPsec in transport mode. So maybe we can try and identify the owners at the very end. So I guess diving into the first proposal, this one, again, doesn't have a reference implementation, but it's just existing as an enhancement proposal right now in the repo. The idea here is to improve the current security arrangement in Submariner. So right now there's a pre-shared key that is mounted in the gateway as a secret and used as part of the IPsec connection establishment between a pair of gateways. So what we would like to do is replace that pre-shared key with an X509 certificate, which is issued per gateway. So in order to do that, what you actually need to do, what you actually need is a certificate authority that's centrally located somewhere within the cluster set. Ideally, I guess, or an ideal location would be on the broker node, seeing as that's kind of viewed as a central location where resources are synced to and from. And this certificate authority would be monitoring incoming certificate signing requests from the gateways that are part of the clusters joining the cluster set. To sync the actual certificate signing requests from the different cluster sets to the broker, a local syncer on each cluster set is required. And equally, to sync certificates that are signed by the certificate authority for the gateways, a syncer is required on the broker node as well. So I guess if we are to zoom into what that actual certificate authority is, the idea in this enhancement proposal is actually to reuse the existing certificates API that already is rolled out with Kubernetes, but to add 2 controllers that will approve the incoming CSRs by essentially checking the identity of the requester of a certificate, and then a signing controller that essentially signs any CSRs that pass through the approval phase. So this means that you don't have to define any new custom resources from a certificate point of view. You can actually reuse the certificate APIs that come with Kubernetes. The only thing that you need to ensure you're doing is to assign a different signer than what is than the default 3 that are enabled in Kubernetes, and that actually works. I've tested that out. It actually works in a pretty neat way. If you specify a new signer on your certificate request, the certificate essentially just waits to be signed by an appropriate signer. So having the controllers to approve the CSR and to sign the CSR on the broker node should be relatively straightforward. And there's also reference implementations for those controllers available in OCM that can be leveraged and reused. Obviously, some of the logic for checking the identity of the requester would need to be modified to make sure that it's a known cluster that's actually issuing the CSR. And then from a signing point of view, I don't think that there will be much different from the existing controller in OCM today. Any questions? Okay. So the general flow is, if you have a certificate authority sitting centrally on the broker node, then it needs to have a root certificate that's passed to all the clusters in the cluster set, similar to what's done today with the broker CA. I think there's a broker CA that's shared by default across all the clusters as a secret right now, that's mounted into the gateways. So something very similar to that would be used, but essentially as a root certificate for this central certificate authority. And that allows the gateway to establish then a chain of trust. So when the signed CSRs arrive at the gateway, it can verify or validate that the certificate authority that signed it was essentially who it expected to sign the cert request. And also when gateways are talking to one another, they can identify the chain of trust again by validating that who issued the cert was a trusted issuer. So at gateway startup, then each gateway installs the central certificate, the central CA certificate locally. It generates a private key, and also generates a certificate signing request with a signer name that can be whatever you want it to be. But essentially, in my example, I'm using submariner.com/broker signer. This CSR will be synced to the broker via a local syncer. When it lands on the broker node, the approval controller will look at the requester, or validate the requester is actually a valid cluster from the cluster set. You can leverage labels or other mechanisms, I guess, similar to labels, if that's what you want to use to do that kind of validation. And then once the approval controller approves or validates the identity of the requester, it updates the status on the CSR to approved. Once the CSR hits an approved status, essentially the signing controller can look at it and sign it, and it can update the status.certificate field with the actual cert that it issues for the gateway. The syncer on the broker node will propagate the issued cert back to the originating cluster or gateway, and the syncer on the originating cluster will pull in this new cert for the gateway, and it'll also verify the signer. That can be done as part of the actual certificate itself. It usually issues a full chain of certs, not just the new certificate, so you can see who the signer was. And then the next step is essentially that the gateway uses the cert as part of its IPsec configuration once it saves it in the relevant IPsec configuration files. Then, when two gateways want to establish a connection, they'll essentially exchange certificates. Both ends will validate that the root authority is who they expect, and traffic can flow from there on in. Does that make sense?
So can I ask a question here, before we go that deep in, we're already fairly deep into this, is this capabilities that, the Submariner team has heard of a need for, for increasing the security posture associated with Submariner? And if so, do you have any kind of idea of when you might consider this? And is there somebody that considers this functionality within their domain ownership?
Yeah, well, this is something that's been, well, not this exactly, but something similar has been requested by ACM. And it's something that we've been talking about for a while. Well, for example, being able to use MTLS for the tunnels and aspects like that. There's also, so this is part of this proposal because it's not part of Submariner, but there's some requests on the ACM side to change the way the Submariner add-on in ACM handles keys. And so that would be very similar to this, but using mechanisms that are present in ACM itself. And obviously Submariner can't be tied specifically to those, but if the mechanics are similar, then well, we should at least be able to come up with common interfaces, even if there have to be two different implementations.
I suppose Rackham could be the central certificate authority, right?
Well, it would be, ideally, it would be when Submariner is running on Rackham, but we still, upstream, we'd still have to support running without Rackham as a broker. So either providing a CA and a signer on the broker as part of Submariner, or just relying on the current behavior. Yeah, so there's, at least I think that there's definitely interest in this. Whether the team has the bandwidth to do it and when, I don't know. Of all the people on the team, this is probably most in my bailiwick. But I think there are one or two people who could be interested in working on this.
Right. So I guess from the enhancement proposal point of view, it'd be great if those that are, most familiar, including yourself, can look at it and decide whether to approve it. And because really, I see this as being somewhat a documented proposal of a way to do it that you might consider going forward, but not in an immediate implementation plan.
Yeah.
So just wanted to try to get the most value out of people's time for doing this stuff.
Exactly. Yeah. That's why, that's one of the reasons why I suggested using adding a status field to the proposal, so that we can actually merge them, even if we don't have overall agreement, so that we don't lose all the work that's been done on this already.
Right. All right. So I'm not sure I see any need, Marion, to dig further into this one, but I think that, the idea is present and the suggestion of a proposed way to do it exists. And I guess if there's any, Q&A based on that, we could talk about it further, or just, request that the folks review it and approve it or reject it, and then, apply the proper status to the PR, and then we can move on. I guess
Sorry.
silence
Yeah.
means move on.
Sorry. Yeah, so the next enhancement proposal actually had a couple of different revisions and ended up with a very focused view, which was around answering the question, how do we enable different cable types between clusters? And I guess the answer that we came up with was actually through the use of a cluster connection policy. This kind of cluster connection policy would allow you to leverage label selectors to determine what cable driver to use between clusters. And really the use case is essentially to enable end users to avoid the cost of encrypted links between clusters that are that share a private link, so they don't need essentially they can leverage VXLAN, let's say, rather than IPsec everywhere. So just on the right-hand side, we can see what we're trying to accomplish. Essentially, we have 4 clusters in this cluster set. One of them is on-prem, and the other 3 are located in the cloud, in the same, I should say, in the same VPC. And 1, 3, and 4 are located in the same VPC, and so they can be interconnected via a VXLAN cable driver, while cluster 2 lives somewhere across an untrusted network. And all the other clusters in the cluster set can connect to it via an IPsec cable type. So this definition, or this, I guess, this type of connection that's shown here, or these types of connections that are shown here, are defined via 2 cluster connection policies. We set up one cluster connection policy, which is the default policy, which essentially says to use VXLAN cable driver for the default type of driver. And then on the second cluster connection policy, we actually specify in the label selectors a left cluster selector and a right cluster selector. So this says that, you know, clusters that are labeled with cloud should connect to clusters labeled with on-prem via an IPsec cable driver. And that was kind of the rough idea behind what that enhancement proposal had defined. One key difference here versus the default connection policy today, which in Submariner is not just to use a single cable driver, but to always connect clusters in a full mesh fashion, is that if you cycle through these cluster connection policies and you don't find anything that applies to you, then essentially, or anything that doesn't apply to you with a left and right cluster selector, obviously, then we don't connect the 2 clusters. We just leave them in a not connected state, which is very different to the current behavior in Submariner. As it turns out, even to accomplish this type of connection definition between clusters in a cluster set is actually quite problematic with the current implementation of Submariner. There's a number of open issues. Several of the Submariner components today have a built-in assumption that there's only a single cable driver and would really need to be refactored before you could even look at implementing and applying these type of connection policies. A very simple example of that is if you look at the endpoint spec, CR, you'll see 2 parameters there, backend and backend config. Backend obviously reflects only a single cable driver, and then the backend config is even overloaded to store all sorts of different information about the connection to the remote cluster, including, you know, NAT discovery ports and whatnot. So there's some work to be done there, essentially, to change that built-in assumption. And then the other open issue that we've noted, based on the discussions around this enhancement proposal, was really the use of port numbers with Submariner. So right now, Submariner is using port 4490 for NAT traversal discovery, which is essentially leveraging a port range that is unassigned to do its NAT discovery, and it's also using port 4500 for all the intercluster traffic. So if you have multiple cables or cable types, then you might have to do or leverage more than one NAT discovery port. So potentially you could reuse the unassigned ports in the unassigned range, which go from 4489 to 4499. And then for the actual intercluster traffic as well, you may want to start leveraging different port numbers, not just 4500, depending on the type of traffic that's being carried across the connection. So this is very much a work in progress, and still, I guess, there's a good bit more work to be done as regards it. So the question really is, I guess, is this something that you guys have seen the need for in Submariner, and is there somebody that could potentially carry it on if that was the case?
Well, before that, I had a question. This looks more
Sure.
like everything that I see on this slide is more from the control plane, right? Like how you define the policy and what would be needed, like opening the ports and all that. One thing I did not find in this, I'm not sure if covered in EP, is the data plane part of it. Reason I bring it up is I remember during early days of Submariner, we tried doing something like that and we had trouble having two different cable drivers on a single gateway. So I want to know, did you try that out? Like from a single gateway, connect one cluster using IPsec, one using VXLAN? Did you try that out, or do you think we will need a multiple gateway, like one gateway per cable driver type to connect to different clusters?
I haven't tried it out manually. I guess it could be potentially done with some hacking of the NAT discovery
right.
piece. Yeah.
No, because I remember, I think me and Ashwin, we had tried out something manual and it did not work that well for us. And at that time, I remember I had a few discussions with Stephen and we were thinking, okay, this is something that could be leveraged with, multiple gateways with the different, each gateway will only support, say, one type of cable driver. So if you have a cluster needs to support 3 cable drivers, it will use 3 different gateways, something like that. And I think with the active gateway code coming in, it might be a bit easier from that perspective in the data plane. Remember, Stephen?
Yeah. Yeah, the problem with that one was figuring out how to get the right traffic to the right gateway. But
right gateway, yeah. But the reason I mainly bring it up is I did not see the data plane part being discussed over here. So I was just wondering, did you cover it in the EP or did not get to that point yet?
No, we didn't get to that point.
Okay, no problem.
So again, is this something that's seen as required capability in the near future for Submariner, or is this something just a nice to have?
Well, we've had it on the nice to have list for quite a long time and never got around to implementing it. So,
and I think 2 good things why we would, it's more than just nice to have, we better have it now is this fits very well with the VPC peering part of it, right? We're trying to define this EP for VPC peering, but we have not been able to figure out how you will define, okay, whether VPC peering needs to be used or not, whereas this would provide a good baseline. The connection policy would go into cable drivers as well as VPC peering. Like if you have 2 within the same cloud and they are using VXLAN, in the backend, transparently, we can set up VPC peering. So user does not need to explicitly do that. That's one aspect of it. And second is, I think from a scale perspective, we will get to a point where we don't want a full mesh. In our previous projects, we have always run into the issue, okay, full mesh works fine at limited numbers. When you start hitting scale numbers of large number of nodes, full mesh doesn't scale well from neither a control plane or a data plane perspective.
Yeah,
so I would say, so I would say the urgency of this would depend on at what point are we going to hit the scale numbers that we want.
I think the connectivity policy, that's a separate story. Independent. They were combined at one point, but they're really separate concepts.
I know it was separate and combined, and it keeps going back and forth. But
yeah, that's why we separate them because connect the full mesh, and initially I was calling that a connectivity policy, but that's separate them.
Yeah, because if you want to completely get rid of this full mesh, then you also have to support this transit gateway kind of mechanism where you support forwarding traffic between the clusters when they're not directly connected, which we don't have currently.
Okay. So
yeah, even with the transit gateways, you can have that. Okay, don't connect clusters which you know are not going to have any data going back and forth between them. But yeah, ideally you would also want a transit gateway to route all traffic to the hub and so on.
Right. So probably one thing that should be done here, Marion, is even update the PR, to describe the need to validate the data plane as well.
Yep.
And I guess just requesting folks review the enhancement proposal and tag it appropriately.
Maybe this update to,
sorry.
I'm just going to quickly say maybe the update to the data plane stuff could be done as an example of a iterative update to EPs. So we could go ahead and merge it with the status field in progress or something, and then add the data plane part as a second PR. Because I know the PR is getting massive.
Yeah.
Makes sense. Yeah, this is a perfect candidate.
Yeah, I already approved it because Maryam had put all these open issues in there. I thought it was. I think did you put a field provisional or something, or what were we using for?
I used deferred because there was nobody working on it.
Deferred. Okay, that's
Yeah.
an official Kubernetes thing there. Okay.
Yeah.
Yeah, whatever to mean it's not ready. It's just kind of put on the back burner. So yes, so Stephen has a -1 on it. So I think I think it would be ready to merge. Although it had a markdown. Okay, well we just have to redo the branch. Update the branch. Okay. All right.
All right.
So
Thank you, Mary.
Steven, if you could take another look at it, at some point.
Yeah.
When you can, that'd be great.
Okay, cool. So the last cable driver enhancement proposal. I guess we started looking at this from the point of view of encapsulation over IPsec and transport mode is seen as an alternative to the use of IPsec, or I guess an acceptable alternative to the use of IPsec in tunnel mode. In addition, leveraging some sort of encapsulation over IPsec and transport mode overcomes the limitations of tunnel mode, which are essentially related to purely static routing. But the motivation, I guess, the three motivations on top of what I just mentioned for enabling this kind of cable driver with Submariner was firstly to allow us to take advantage of the performance optimizations that come with IPsec offload in bare metal. So the existing IPsec tunnel implementation performance between a set of servers was accomplishing something around 2 gigabits per second. By leveraging certain types of encapsulations over IPsec and transport mode offloaded, you could actually accomplish line rate depending on the adapter that you had. For VXLAN specifically, offloaded over IPsec and transport mode, you can get around 9 gigabits per second. Obviously, the other encapsulations with the better line rate were was a GRE over IPsec in transport mode, and from a logical point of view, I guess the other benefits still apply, even if you don't for VXLAN, even if you don't accomplish the same level of performance that you get with the GRE offloaded over IPsec and transport mode. And why I stuck with VXLAN really for this enhancement proposal and for the implementation was due to feedback on the enhancement proposal that suggested that VXLAN was already supported as a cable type for as a cable type in Submariner today. So could we, you know, leverage that with an IPsec transport configuration, which was kind of interesting because from an implementation point of view, you actually end up reusing everything that's in, excuse me, the VXLAN cable driver code, and you know, just adapting some of the IPsec or the LibreSwan cable driver code to allow it to operate in transport mode rather than tunnel mode right now. The second thing, I guess, that you get with this type of cable driver is that you can leverage dynamic routing between Submariner gateways. So IPsec in tunnel mode essentially leverages static routing. So you have to manage the security associations between, you know, interconnected gateways, and you have to update them. And that's something that's currently done in Submariner today. I believe there's a watcher on the connection endpoints that's constantly monitoring for new connections coming up or for connections going away, and it's either adding security associations or removing them. I guess when you have to scale that up to a large number of gateways, that comes at a cost, because dynamically changing security associations essentially is that kind of setup is orders of magnitude slower than leveraging a simple routing change. By adding something like VXLAN in front of the IPsec connection and operating it in transport mode, you get rid of all of those complications because your security association changes from having very specific static routes or filters into a more trunk-like connection, and I can show you that on another slide in a minute. And then I guess the question here then is, from Submariner point of view, you know, what's the upper limit of the number of clusters that you see operating in a cluster set? Is that a sizable number? You know, if it is, then maybe dynamic routing is something that you may want to consider as a feature to take advantage of. If it's not a sizable number, then I guess the current way Submariner does things is probably okay. And the last thing that you get with the this new cable type is essentially the capability to follow packets through the network, which is a little bit easier than trying to follow stuff in tunnel mode. So I guess so just for my first question, you know, how many clusters, or what's the upper limit on clusters for the use cases that Submariner is looking at?
Maryam, I think I've heard tens of clusters versus hundreds or thousands, you know, at this point with Rackham. But I think, you know, since it's not really a generally released product, you know, I think some of that will come over time. But, you know, one thing that I would mention here is that, you know, it's not exotic hardware that has this hardware exist. It's you know, the standard NICs that are out there, 10 gig NICs and so forth that would support this. And this is probably the I don't know, lowest barrier to entry as far as development and stuff and capabilities that you would get, you know, as far as these enhancement proposals go.
Yeah, one of my servers at home has a 10 gig NIC that supports all this stuff. So yeah, it's not exotic, definitely. And I would say it's not even really about, at least in terms of customer perception, it's not even just really about the number of clusters that get connected, but we've had, right from the beginning, we've had customers, let's say, dismayed that Submariner added, well, caused so much reduction in available bandwidth on their links. They were happy with their 10 gig fiber connections, but then they were only getting about a gig over them.
So this would push it back up to close to line rate for those connections.
Yeah. Even so, just to talk about it from a slightly more technical viewpoint right now. So the IPsec connections are accomplished through definitions in two databases, I guess, a security association database and a security policy database. So the security policy database essentially is applied on each packet, and that essentially identifies, let's say for an outbound point of view, it identifies which security association applies to the packets that it's looking at, and eventually, once the right security association is identified, the packets are encrypted and sent along the correct tunnel. So with the IPsec tunnel mode configuration that's set up with Submariner today, you actually end up with 4 connections between, let's say, 2 clusters. So you have the pod-to-pod CIDR, the service-to-service CIDR, and then you have pod to service and service to pod. So you have to do all of these, you have to set up all of these connections just between, let's say, a pair of clusters, which eventually explodes into something like this. So this is an equivalent configuration from an IPsec point of view to what Submariner is doing today. These are the active traffic status connections between a set of clusters. These are, I guess, the policies that are applied on a packet by packet basis, and these are the security associations. And actually, I ran out of space, so I put in a ... for the rest of them. And this is just for one connection between two. Sorry, this is just for the connections, the tunnels between 2 clusters. So when we move to IPsec and transport mode, that simplifies greatly. Essentially, we say that we want to interconnect the 2 gateways based on the relevant IP address. Unfortunately for VXLAN, unlike IP and IP, you end up having to set up a route for outbound packets and or I should say, a connection for outbound packets, and then a connection for inbound packets, because we're filtering on the VXLAN port. So the resulting configuration or associations is much is greatly reduced. You end up with 2 security associations. Actually, unfortunately, I didn't print off. I didn't show the actual SAs. I'll update the slide after the call. But you can see from the policy point of view, again, you're going through a much reduced set of lookups to essentially tunnel packets or transport packets in the right security association between a set of clusters. But from a higher level point of view, essentially, what happens is with the transport mode, rather than the 4 connections we see between a set of cluster sets, you end up with 2. And because I'm only showing the outbound traffic here, I'm only showing one of these connections interconnecting, a single Submariner gateway to another cluster. And then the other kind of really important thing to note is that because we're operating in transport modes, the VXLAN header is readily available and usable from a routing point of view before we start looking up the right policies and associations in the security policy database and security association database. So hopefully, leveraging something like VXLAN over transport mode would allow, Submariner to take advantage of the existing routing support that's in the Linux kernel, rather than trying to have everything managed by Submariner itself, while also taking advantage of the performance gains that it gives. And that's really kind of what the goal of that enhancement proposal was. From an implementation point of view, what I did was actually enabled a new cable driver, which was called VXLAN-LibreSwan. The reason why I did it as a new cable driver was due to some of the discussion on the enhancement proposal, which suggested that Submariner wouldn't necessarily support both types of cable drivers, that potentially it would look to replace the existing tunneling support with something like this. So I just thought, actually having discussed it with Donald, we thought that it would be easier from a refactoring point of view to be able to just cleanly delete some files rather than having to do some sort of complex refactoring. So yeah, from the point of view of what actually happens on the gateway node, and I'm sorry this isn't as clear as I'd hoped. I can try and clear it up in another zoomed in version of this diagram, but I'll do that after the call. You still end up with your normal VXLAN tunnel interface, traffic to and from the pods, and to and from the pods essentially gets routed through this VXLAN tunnel interface. It actually gets encapped with the appropriate VXLAN header information. And then the IPsec configuration basically is looking for a certain source address, destination address, and let's say the destination, the VXLAN destination port, which will consume all the VXLAN traffic coming towards a specific other gateway, I guess, in another cluster. Tunnel it or encap it with the ESP header, and then send the traffic across to the other cluster. On the other cluster, the ESP header gets interpreted and removed. The payload of the IPsec packet gets decrypted. It's still a VXLAN packet, so it gets rerouted to the appropriate VXLAN tunnel. And then eventually, hits the appropriate pod or interface. So this looks a lot, I guess, like the existing Submariner implementation for the VXLAN tunnel, except obviously you'd have an interconnection here. All we've done was introduce another hop, I would say, a very minimal hop from an IPsec point of view to encrypt the payload of the packet. And still, route traffic across the different CIDRs and interconnect two clusters. And the reference implementation is readily available for folks to reuse or edit or do whatever they want with it, really. So I guess the question is, encapsulation over IPsec in transport mode, is that something that Submariner foresees as something that it needs, or?
Yeah, as Stephen mentioned, I think one of the motivation for us to look at this particular proposal is mainly not just for the performance, but I think like even from debuggability point of view. Today, although we're not seeing many issues with IPsec because it just like works most of the time, but however, if you're running into any issue, like one of the challenges that we have with debugging is that it's really hard, as you pointed out in your spec, that it's really hard to debug like what is traffic that is going over the tunnel. So I think having something like this transport mode where you are exposed within VXLAN interface would help us debug any issues at much more quickly.
Yeah,
Yeah. And one another question, like, I think at the bottom you mentioned that, the hardware offload is typically only supported for AES GCM, which is not default in LibreSwan. Like, do you think that, if we tweak the encryption algorithms in LibreSwan configuration, will it actually, improve the performance, at least where you have a hardware offload significantly?
According to the measurements that Anton did, he saw significant improvements for sure. And I guess the thing to note is that actually LibreSwan itself is actually capable of picking up the automatically picking up the hardware support. So if you pick the right algorithm on your IPsec configuration, it should automatically be able to take advantage of the hardware that supports that, So I do think you should see some significant performance improvements.
Yeah, and I think the gateway container image does the right thing. So we don't do stack manager start exactly, but we do the same thing. So we mount all the modules in the container so that they can be loaded, the kernel modules.
Yeah.
Yeah, so just on that point, I'd done a bit of prototyping just to change the parameters going into the IPsec commands so that they would choose the right ESP encryption profile, which is the AES JCM 128 profile. And it was definitely enabling hardware offload just by changing the encryption profile. The problem being that tunnel mode is typically not supported or is broken in offload. So you need to implement what Maryam's described in order to actually make use of it.
Yeah. And so by broken there, do you mean that if
it doesn't work
in a current setup, if we somehow change to AES GCM 128, then and still stay in tunnel mode, then things could just fail?
No.
No.
So on older kernels, it would just fail to do offloaded encryption and fall back to
Okay.
to CPU
on
based.
core.
And
it was disabled in the actual driver, right?
Yeah, on newer kernels, it's disabled in the driver.
Right. Okay.
So the net is you can change the encryption, but you're not going to get any benefit from it unless
yeah.
unless you,
but
you change.
What I was worried about was if some settings could cause the tunnels to just not work at all.
Oh, right. Yeah.
Yeah. So it doesn't appear to be the case because the way the offload is implemented in the drivers, if it fails to register or function on the card, so it may offload parameters to the NIC, but the NIC communicates back whether or not it performed decryption or encryption.
Yeah.
And so that gets communicated back to user space, so user space can still do it.
Yeah.
Or not user space, sorry, kernel space can still do it.
Right. Seems like there's a lot in play, right? So this is probably, I would consider, the lowest barrier to entry to like get, an enhancement, but being able to selectively decide what you want to what tunnels you want encrypted is equally valuable, because if you see a customer has Submariner in a VPC, and within the VPC they don't really care about the security of that tunnel, right? But they're paying a significant penalty by having an encrypted tunnel between the gateways within the same VPC.
Yeah, and just the last thing to add as well, and may or may not be of interest, I guess, but excuse me, IPsec in tunnel mode supports only unicast traffic. So if in the future Submariner foresees a situation where it wants to take advantage of L2 or L3 VPN capabilities and features, you're going to have to enable some sort of encapsulation over IPsec anyway. So I'll just leave that there. Yeah, so I guess the enhancement proposal is there. I've updated it with all the implementation details and so on. I guess it sounds like this could be something of interest to the Submariner team. So is there an owner for this, or should there be?
Somebody on the
I
data
think
plane, maybe?
it all boils down to like, the bandwidth, but I am definitely, interested in this along with a couple of other members from the team who probably are also interested to look at it. Yeah, Stephen, you were saying something? Please go ahead.
Yeah, I was just saying maybe somebody that's already working on the data plane. So I was thinking of you, or Ashwin or Vishal.
Yeah. What's the status of the EP on this one?
It's the same at the moment. I put in as deferred because nobody was working on it. Yeah.
But this comes with the reference implementation, so it's like somewhat further along as far as ability to adapt it to the current Submariner.
Yeah.
And as you mentioned that this is like you call it a different cable driver itself. So I think from the control room perspective, there's nothing much we done, right? You just say VXLAN over IPsec as the cable driver, and that's it, right?
Yep, pretty much. That's what I did. So I put it in as VXLAN/Libra1, but you can rename it whatever you want.
Right.
Yeah. And then it picks that cable driver, sets up the VXLAN interface, sets up the IPsec associations, and then traffic just gets routed to the right places and encrypted, pretty much.
Nice.
Cool. Okay, great. That's pretty much what I had for today. I guess if there's any other questions, I'm happy to answer them. The deck I've put into the minutes here, and just at the back end, there's a reference to all the enhancement proposals, the reference implementation for IPsec for VXLAN over IPsec in transport mode, and just a couple of interesting papers and presentations I found around dynamic routing and IPsec. I said I would share with the team.
Thank you, Maryam. Nice summary, and thank you for all the hard work that you and your team were working on. I appreciate
No problem. Thank you, guys.
Thank you. Excellent job presenting, Maryam.
Thanks, Ian.
Yeah, thanks, man. It's pretty helpful.
Bye-bye.
Cool.
It
Thank you,
certainly would
everyone.
be good for anybody interested in them to take a look now and while